that. And gotta make this. Okay. Okay. Man, sorry, I am totally about to start your question, but I have to make a screenshot, a shortcut, because screen shooter. What is this going to be? That's got to be it. Because I can never remember what my screenshot is. Just like reinstall. No, that's it. Is it going to save it? Man, I just want you to save it. Save. Okay. See, I can't go through this every time. Let's see, screen shooter. We don't want screen shooter. Come on now. Dash S. Boom, boom, boom. Okay. Let's go. Windows. Edit. Cancel. Edit. Dash R. Dash S. Alright. Come on, dude. Just say that. Okay. Well, let me just get rolling on this so I don't waste too much time. Open. Okay. Alright, this is our problem here. So Aurora is planning to participate in an event at her school's field day that requires her to complete tasks at various stations in the fastest time possible. To prepare for the event, she is practicing and keeping track of her time to complete each station. Okay, cool. The x-coordinate is the station number and the y-coordinate is the time in minutes since the start of the race that she completed the task. Alright. The x-coordinate is the station number and the y-coordinate is the time in minutes since she started the race that she completed the task. Y-coordinate is the time in minutes. See, this is a little ridiculous because they don't actually mean what they're saying here. Man, this is not good. Alright. Guess I'm just gonna rock with it. Changed a bunch of settings and just messed everything up. Okay, there it is. So one thing to note is, like, if this is X and that's the station number, and then this is Y and it's the time after since the start of the race, then the station number is the independent variable, which doesn't make any sense. They actually want it the other way around. And probably half the reason why this is confusing you is because of that. Nevertheless, we still need that in order for this to be either arithmetic or to be geometric. So we're just going to go with it. Alright, so is this data modeling an arithmetic sequence or a geometric sequence? So this is part A. Let's recall that arithmetic sequences have a common difference, D, and geometric sequences have a common ratio. So that's really important. And if you'll notice, our first term, let's call it A1, is 3. A2 is 6. A3 is 12. And A4 is 24. So if we look at the difference between these, it's 12, and the difference between these is 6, and the difference between these is 3. So the difference is not common. 3, 6, and 12. So difference means subtraction, right? So we take the later one and subtract the earlier one. Just get my life together as soon as possible. Okay. Oops. We don't want that. We just want to get rid of these. Okay. So let's check and see the common ratio. If we take 24 and we divide that by 12, which is the one before it, we get 2. If we take 12 and we divide it by 6, we get 2. If we take 6 and we divide it by 3, we get 2. So this is the ratio of a term to the term before it, and it's common to all of those. So by definition, that's a geometric sequence, which is cool. So we know our thing is geometric. So is the data modeling an arithmetic or geometric sequence? Boom. We could say geometric because there's a common ratio. Geo, because the common ratio is 2. All right, let me just get this out of the way. There it is. Goodness. Is 2. All my settings are messed up, so I'm going to be way slower than I normally am. Use a recursive formula to determine the time she will complete station 5, show your work. So recursive means it feeds back into itself, right? So we need that version. And then it like recurs, it happens again. Does that make sense? So then use a recursive formula to determine the time she will complete station 5. Okay, so basically they're saying we need to predict this number here in the sequence. So A1 is equal to 3. Then AN is equal to the n minus 1th term, the one before it. So this is the term we're on. This is the term before that. Whatever the index there, n is, it's one lower. That's what n minus 1 means here. We multiply that by 2. So actually, let me write this in a better form. This would be 2 times the term before n. Okay. So this is the recursive formula, and then we can say A5. So here I'm plugging in 5 for n is equal to 2 times A sub 5 minus 1, which is equal to 2 times A sub 4. 5 minus 1 is 4. And then we can look up the 4th term, which is 24. So 2 times 24, and that equals 48. Then we just, write that however you want to, like report that however you want to. This is 48. Maybe box it. I don't know. This is part B. B. That whole thing is B. Sorry, this is really difficult because my tablet is not onto. Oh, thank you. Not onto just one monitor. It's like stretched across both monitors, so everything's off. Okay, so then part C, use an explicit formula now. So before we did the recursive formula, now we want to use explicit. See, the recursive one depends on A1, but we want a term that doesn't depend on A1 exactly, right? We want to say what every term is. So the way we say AN is equal to, we start off with like whatever A1 is here, and then we, since it's a common ratio, we're going to multiply it by the common ratio. We want it to be raised to the, and actually, why don't even, yeah, let's say it that way. Boom, boom, boom. Let's say, there's different ways you can do this. I'm going to do n minus 1. All right, so this is how we create the formula. So A1, we want it to be equal to 3. So this is 3 times 2 raised to the n minus 1. Now 1 minus 1 is 0. And then actually let me just update this. 3 here. Okay. And then 2 is 2. Alright, so A2 is going to give us 3 times 2 to the 2 minus 1 is 1, which is 6. Okay, that worked out too. A3 is equal to 3 times 2 to the 3 minus 1, which is 2. 2 squared is 4, 3 times 4 is 12. Okay, so this works out. Looks like our sequence is good. It says, use an explicit formula to find the time she will complete the 9th station. Okay, so this is cool because you don't need to generate, 6, 7, 8 in order to feed it in using the recursive method. So just get rid of that. So yeah, let me just go ahead and put, so you're going to do like A1 times R to the n minus 1. That's your formula. And then this is going to be, and that's depending on how you want to index. 3 times 2 is the common ratio to the n minus 1. So that's our formula. And then so A9 is going to equal 3 times 2 to the 9 minus 1, which is 3 times 2 to the 8. That's going to be 8 times 8 times 2. No, 8 times 8 times 4. So this is 3, or let's go 3 times 64 times 4, which is equal to 12 times 64, which is equal to, let's say, 600 plus 40 plus 120 plus 8, which is 768. I think. Plug that in your calculator and check. I'm too lazy. Alright, yeah. Sorry for making you wait there at the beginning. If you have any questions, I'm going to keep this problem here just like tucked away. We can bring that back up whenever. But I'm going to try and fix this computer before I go on. So, yeah, if you're watching, say what's up and all that in the chat. So I installed. I wanted to like have the ability to dual boot different versions of Linux because one was giving me a problem with audio stuff, and like I thought I'd switch to Ubuntu Studio, which is more geared towards that. But then I have a different desktop manager on this one, which is XFCE, and then the other one I'm used to, I think, is GNOME. And all my hotkeys are messed up, and I have like all these solutions I had worked out over the last like 2.5 years that I've been using Linux to the little like customizations I want, and they don't work on this version anyways. The long story short. So I'm figuring that out live, which is embarrassing, but whatever. So what I'm gonna do? So yeah, go to xfce.com. See, that's the great thing about Linux, though, is like everything is possible. Oh, yes, okay. So I found it for, I think this is right. I think this is the exact command I need. I know y'all can't see that, but let's see. Oh, dear baby Jesus. It's almost perfect. So this is going to be 0, 0, and then we're going to do 1920 times 1080. Come on. Let me think about how this is formatted. Offset X, offset Y. Width of projection, height of projection. So that's going to be the same. Okay. So that's right. The last two is offset X. So I want to offset it 1920. Is that going to work? Oh, yeah, come on. Okay. Oh, I had an extra 0 in there. 19,000. Ah, there we go. Now we're cooking with gas. Okay. Solving problems while I solve problems. And let's get some new questions. So, going back to homework help. What is this cheetah math? Let me just refresh this, see if we got new questions. Calculus, simultaneous equations. It's my favorite. Alright. I just made this out. Come on. And boom. so bring this in. Okay. Oh, that's the last one. Undo. Import images, date modified. That's descending. No, did I not save it? Where are we at? Come on now. Save. Import. Add images. Oh, okay. Upside down. There we go. So I have homework which has two tasks. One for a question which goes something like, Lana is responsible for buying office stationery for her coworkers. Use the above formula information to determine whether or not the price has changed from previous weeks. Okay, weeks 1, 2, and 3 are part of task 1. Weeks 4, 5, and 6 are part of task 2. Now, task 1 has a unique solution which I just put into my graphical calculator, however, task 2 does not. It is a consistent solution with an infinite number of solutions. 3 planes intersect in a line. I have the same equation after interpolating the 3 previous equations, which are okay. Okay. Does it tell us the cost? Yeah, we don't have enough information. Sorry. I think the best way for you to do this would be screenshot me the question. I'm going to edit my. If you're in here, I'm going to edit my response to you. But we need more information. Yeah, hopefully you see this or hear that. Okay. Following graph represents transform functions. State the base function. Alright. This is good. Okay. I love it. Alright. Working on your problem in my live stream starting at 25 minutes. I'm gonna be perfectly honest. The only reason why I'm saying is because they won't let me ask y'all to like and subscribe and stuff like that in my post on Reddit. The mods don't want me to do that, which is cool. It's like, I get it. They don't want people coming and pushing their channel, but at the same time, you know, it's really not like it's not that big of an ask. I feel like doing all this homework. I like it though. I like to do the homework. Boom. All right. Okay. The following question are not related. The following graph represents a transformed function, so it's transformed from some other function. State the base function and the equation of the transform function. So with this, like, you just need to have a little bit of familiarity with these functions. You're going to need them for calculus. This looks super cool, this like pattern here from your cell phone picture. But this is recognizable. This is the same thing as, it's like a transformation of, man, this is going to drive me nuts. This is a transformation of 1 over x, which I'm going to draw really poorly. So at first look, it looks like this is just shifted to the right by 1 and up 4. And so when x equals 1, you would have 1 over 1, which is 1. When x is 2, you would have 1 half, 1/3, 1/4. Yeah, that looks about right. Okay, cool. So yeah, this is, like, let's say f of x equals 1 over x. Then this is f of x minus, we're shifted to the right 1. So if we change the argument, if we do our subtract inside the argument of the function, which is in these parentheses right here, that does a shift to the right by whatever that amount is. So this becomes this. Then we have to also shift up 4. So I'll add 4 to both sides of this. Over x minus 1 plus 4. Okay, so yeah, that's it. That's our function. Oh, my bad. We actually want to do it to both sides of this. F of x minus 1 plus 4. Okay, and then let's just call this function our function. That's our function there. And then I could probably simplify this on the right. I mean, I don't know if simplify is the right word. I can like make it look a little prettier by giving it a common denominator. So I'm adding fractions here. So this is 4, and then I'm going to multiply this by 1, which I'll represent as x minus 1 over x minus 1. And then I'm going to distribute my 4, 1 plus 4x minus 4 over x minus 1, and then I will simplify the numerator. So this is going to be 4x minus 3 over x minus 1. So yeah, you could just give this as your answer here. This could also be your answer, whatever you like. And if you want, it's not in the imgur, but if you come in here and like say, hey, I'm the guy that, or the person who posted that other question about 1 over x, I updated my post. I'll go back and do the rest of that if you have more homework. Like, since we're cheating, we might as well cheat, right? Econometry? I don't even know how to say that. Let's see if they answered this calculus homework. Your given velocity. Whoa. All right. I'm just going to do this whole thing since why not? 30 minutes. Okay, comment, and then let's go. So I'm just going to kind of do these one at a time. And this could go off. particle moves along the x-axis so that at time t greater than or equal to 0, its position is given by this function. Okay, so this is x of t, which means it's probably its position on the x. Oh yeah, of course, they said that. It moves back and forth along the x-axis. At what time t is the particle at rest? So what does it mean to be at rest? It means your velocity is 0. So if this function x of t gives the position on the x-axis, its derivative will give us the velocity. So the rate of change of its position is its velocity. So when its velocity is equal to 0, that's when we know it'll be at rest. That's the key to understanding this problem. So what we want to do is let's bring down x of t, just so we've got it down here. T cubed minus 21t squared plus 72t minus 53. Okay, so this is our position function. We're going to take the derivative of this and get x prime of t. X prime. We got, just using the power rule, 3 times 2 is 6. Okay, t to the 3 minus 1 is 2. Power rule again, 2 times 21 is 42. T to the 2 minus 1 is 1, which we don't need to write that. Plus 72t derivative gives us just 72, and the derivative of our constant is 0. Okay, so this is our velocity function. Now we want to know the time or times at which this function is at rest. So we need to set this equal to 0 and solve this equation. Just looking at this really quickly, it looks like all of these are divisible by 6. So I'm going to go ahead and divide both sides by 6. So I get t squared minus our speed and velocity the same. That's a really good question. That's super meta. Not quite. So speed is the absolute value of velocity. It's the magnitude of the velocity. And velocity is directional. So velocity is a vector value function, and then so vectors have size, they have magnitude, right? But they also have direction, whereas speed doesn't have direction. It's just got size only. Good question. 7 plus, what would this be, 10, 12? Can't math, plus 12. Okay, so let me make sure I did that. 6 divided by 6 is 1, 42 divided by 6 is 7, 72 divided by 6 is 12. Okay, boom. All right. And then let's try to factor this. I think, oh yeah, we can factor this. So we know we need a t here and here. This has to multiply to be 12 and add to be negative 7. So the only way you can add to be a negative number is if both factors are negative. And 4 times 3 won't get it done. So that's cool. So this means either t minus 4 equals 0 or t minus 3 equals 0. That is the zero product principle. If you multiply two numbers together, which are this one and this one, if you multiply two numbers together to equal 0, one or both of them has to be equal to 0. Okay, and then we solve these. I add 4 to both sides. I add 3 to both sides. And so at either of these times, our velocity will be 0. Yeah, and that's the answer here. I probably shouldn't have done that. I didn't notice that you had done that problem. So let me go turn that off. Let's bring in another problem. Here we go. Calculator not allowed. You're the calculator now. Similar question. For time greater than t equals greater than or equal to 0, the velocity of a particle moving along the x-axis is given by this function. Okay, we got another horizontal movement situation, but now instead of giving us the position, x of t, they're giving us the velocity. At what value of t is the acceleration of the particle equal to 0. Okay, so in order to do this question, again, we need to know that the derivative of the velocity function gives us acceleration. So we have to take the derivative of this. And really notice that this is a product of two functions. This is the product of t minus 5 and the product of t minus 2 squared. Okay, so let's use the product rule here to take the derivative. So everybody remember, I don't want to use v because v is here, so it's like if you have f and g multiplied together and you take the derivative of these, it's f prime g plus f g prime. Okay, so the derivative of the first is 1 times the second, which is t minus 2 squared, plus the first times the derivative of the second, which is 2 times t minus 2, and then you would have to do a chain rule. Sorry. Okay, yeah, we're cool. And the derivative of the inside is 1. And then let's just simplify that. So this is v prime of t. So we've got t minus 2 squared plus 2 times t minus 5 times t minus 2. So I didn't really do anything other than bring this out front, get rid of the 1. And then I see that I've got a common factor of t minus 2 here. So I'm going to pull that out. And then this is going to be times t minus 2 plus 2t minus 10. So I also distributed this 2 at the same time. And then, oh, you know what? This is all unnecessary. I'm not even going to do that. Actually, maybe I'll leave that one. Oh, no, I need to do this. But we can, once we simplify this, we can leave it there. So we've got t minus 2, and then we've got, so t plus 2t is 3t. And then negative 2 plus negative 10 is negative 12. Okay, so we're trying to find where the acceleration is equal to 0. We took the derivative of the velocity. That is the acceleration function. So we have to set this thing equal to 0. And we'll just solve this equation. And you know, it's basically solved. It's already factored for us, so we're going to use the same zero product principle. Either t minus 2 equals 0 or 3t minus 12 equals 0. So we'll add 2 to both sides, add 12 divided by 3. And these is obviously in seconds. I should have probably put that on the, whatever. I should have put that on the last one too. Yeah, 2 and 4. So 2 and 4. Boom. All right. Let's do another one. Oh. Okay, Cody, I saw your chat, and I will pull yours up next. We got a couple more with this one, but you're coming up right after. Save. And I'll try to go a little fast with these. Oh, is that right? That's right. Okay. Yeah, you're very welcome. Thanks for coming into the stream too. Like chatting and all that stuff. It helps the channel a lot. So really appreciate it. Okay, a particle moves along a straight line. The graph of the particle's position x of t at time t is shown above. So it moves along a straight line, and then its position function is this graph at time t. Okay, and then t is between 0 and 6. The graph has horizontal tangents at t equals 1 and t equals 5. Yeah, cool. So for what values t is the velocity of the particle increasing? Okay, cool. So let's think about this. This is the position function. The derivative of the position function gives us the velocity function. Then if you ask a question about whether or not the velocity is increasing or decreasing, what you're talking about is the rate of change in velocity. Okay, so this happens to be the second derivative of x. So if we take x double prime of t, this is equal to the velocity derivative. So really what we're asking about is concavity of the position function. The second derivative of a function gives us its concavity. So if our velocity is increasing, we can tell that because that would mean this is positive, which means this is positive. So the second derivative of the position function is positive. So where is it concave up? It's concave up from 0 to me this looks like, somewhere in between, I would say 3. I would say 3 is where it changes. Which is is it 1 to 5? Be from 0 to, oh, okay, maybe it is 0 to 2. Yeah, maybe it is 0 to 2. That's really tough to call. This is why I don't like doing things off graphs. But definitely it's 0 to something, so it's got to be A. Yeah. And I don't know if you need to justify this. It looks like you have some of these right, so I'm not really sure why or what you need on these. Since you paste them all, I'm just gonna do them all. And we're gonna get to you in a second, Cody. I'm sorry. We got 3 more multiple choices. Okay, a particle moves along the x-axis with velocity given by this function for time t greater than or equal to 0. If the particle is at position x equals 2 at time t equals 0, what is the position of the particle at time t equals 1? Okay. So particle moves along the x-axis with velocity given by this function for time. Yeah, I don't know if you know integration yet, so that makes this kind of tough. But so the integral of v of t dt is going to be equal to the position function plus some constant. Okay, we can actually find that. So let's take the integral of this thing. 3t squared plus 6t dt is going to be equal to, this is going to be t cubed plus 3t squared plus c. So this is the position function. And we can just use, we're told that at t equals 0, our position is going to be 0 cubed plus 3 times 0 squared plus c. And we're told that this thing is equal to 2. So this is 0, this is 0, so c equals 2. So I can update this function here. Okay, so that's our position function now. So then what is the position of the particle at time t equals 1? So we're going to do x of 1 is equal to 1 cubed plus 3 times 1 squared plus 2, which is equal to 1 plus 3 plus 2, which is 6. All right, two more. And I'm just going to put both of these at once, so I don't have to screenshot so much. Yeah, and you can, if you have some big homework coming up, DM me as soon as you get the problem, because I don't stay on Reddit very much unless I'm actively doing a live stream. But you know, if I can get the flow of what your homework is, I'll just, you know, I'll set up a live stream whenever. I'm trying to do them every day, honestly. All right, so the velocity of a particle moving on a line at time t is whatever. How many meters did the particle travel from t? Okay. So for me, this is not talking about its displacement. It's talking about like how far did it go altogether. So we got the integral from 0 to 4 of absolute value of 3t to the 1/2 plus 5t to the 3/2 dt. And this is going to be like how much we traveled. So let me think about this. So this is always going to be positive, and then this is always going to be positive too, so we're good to go there. We can just get rid of these absolute values. Okay. All right, so we'll use a power rule. This is going to be 3t to the 3/2 over 3/2 plus 5t to the 5/2 over 5/2, and then evaluated from 0 to 4. Then I'll just cancel this, and that brings the 2 up to the top. So it's like 2, and I factored out 2. 3/2 plus t to the 5/2 from 0 to 4. So 0 is just going to zero out, so really we just need to do for 4. So this is 2 times 4 to the 3/2 plus 4 to the 5/2, and that's going to be 4 is 2 squared. So this is 2 squared to the 3/2 and 2 squared to the 5/2. And then we just multiply the exponents. So this is 2 cubed plus, whoa, nice 3 line, plus 2 to the 5th. And that gives us 2 times 8 plus 32, which is 40 times 2 is 80. And then, okay, if the position of a particle on the x-axis at time t is negative 5t squared, then the average velocity of the particle for t from 0 to 3. Okay, so the average value of a function, so let's call it the average velocity. So the average velocity, I'm going to call that the average velocity, is equal to 1 over b minus a, which comes from the bounds, times the integral of the velocity function. And this is, you know, this is a theorem in your book, so if you don't have that memorized, it's like, you know, if you pop in and ask about it, I'd love to explain it, but for now I'll just do the homework since that's probably what you need the most right now. So first we got to find v of t. Right now we have the position function. So the velocity is the derivative of the position, so let's take the derivative. So x of t equals negative 5t squared. X prime of t, the derivative, is the velocity function. And so we've got negative 10t. So we're going to plug that in. So the average velocity is equal to 1 over b minus a. b minus a is 3 minus 0, which is 3. Integral from 0, and I should put a and b here as well, from 0 to 4 of, oh, this is me being stupid, negative 10t dt. If I'm about to take the integral of this, it's this, right? So I didn't really need to go through that whole mess of taking the derivative. to get this. Like, I know what the antiderivative is. So this is just negative 5t squared from 0 to 4. I guess it probably helps to elucidate the, what's going on, but if you know that, you don't have to go through all that mess. The integral of the derivative is, the function back. Okay, so then we got 1/3. Why don't I pull out the negative 5 too? So it's going to be negative 5 over 3. We're going to evaluate this from 4 squared minus 0 squared. Okay, this is 4 squared, so this is 16, which is so negative 80 over 3. Yeah. And let's think about that. Does it make sense? It's average velocity. So if your velocity can be negative, since it's a vector function, negative implies like backwards or left, since it's on the x-axis. So we're cool with that. That's fine. And I don't know if we need units. Does it? Oh, wait, hold up. Oh, this is my mistake. The time interval is not to 4. This is big bad mistake. This is not 4. This is 3. Okay. So 3 squared, and so that's negative 5 times 3, so negative 15. And I was just looking at that. I don't know if, yeah, we did have negatives. Okay. Wouldn't have noticed that unless it was multiple choice, so that's a bummer. All right, Cody, you're up. Let me check my DMs. Yeah, that's wild. It doesn't even give me that, like, what's it called? Notification. All right, cool. The following questions are not related. Oh, okay. Did I do your earlier one? Import, add images. Okay. The following questions are not related. Consider the function g of x equals 5x squared plus 20x minus 10. Okay, so we got some function. Determine its inverse. Oh, okay. So let's really think about this. I'm going to graph this, or like sketch the graph. I don't really care if it's the actual graph, but so we've got some function here. And then this is like 4, 2, oh, that's not you? Okay, let me, that's today, so somebody posted that, so we'll come back to that. Student instruction sheet. Is yours the one with the bananas? Oh, okay. That's one that I looked at earlier too. Yeah, I got you. Okay. Accept. Alright. Is this calculus? Okay. So I'm just going to do this whole one screenshot. Okay, so Danielle works at a kindergarten and is responsible for buying fruit each week to serve the children for morning and afternoon teas. Week 1, she buys whatever. Ah, see, that's what we needed was the total cost. Use the above information to determine how much each type of fruit costs per kilo. Okay, is it the same cost? Ah, I got you. So in the first question, we figure out the prices, and in the second question, we figure out the new prices and see have they changed. That's the idea of what's going on here. So let me Okay, so week 1 she buys 3.4 kilograms pears. So let's say 3.4 times the price of the pears plus 1.7 times the price of the nectarines plus 6.4 times the price of the bananas. And this is equal to 30.78. Then we got 3.9p plus 2.2 n plus 5.1b equals 34.28. Now, in this model, we are assuming that between the first, second, and third week, the price does not change. And to me, that feels like a dangerous assumption, just understanding how prices of food change rapidly. But, you know, you kind of have certain limitations with these problems in math. Okay, so here's our system of equations. There's a bunch of different ways to solve this. I like the elimination method. So the first thing I'm going to do is kind of get rid of all of these decimals. I'm going to multiply. Actually, I'm not even worried about it. So let's take this equation. I'm going to multiply this one by 3.9. I'm going to multiply this equation by negative 3.4. And that's going to give us a new system. For this process, yeah, that's why I was whenever I first originally tried yours, I was like, I don't really know what the objective is for the function. I thought it might be cost based on the wording, but I didn't see any cost data in there. So basically, what I'm doing is I'm finding the LCM of this number and this number, right? And I'm going to use that so I can cancel this variable out of the second equation. And you'll see why in a second, but that's the process. I'm going to do it again with the 4.8 as well. So we got to do 3.9 times 3.4. So I'm going to even change the color right here so you see the new system. This is going to be 13.26, 13.26 p 3.9 times 1.7, 6.63, and 3.9 times 6.4, 24.96, and 3.9 times 30.78, 120.042. Then I'm going to multiply this by everything here, and then I'm going to add equation 1 to equation 2. So we'll do negative 3.4 times 3.9 plus, actually, here, let me not even, so basically the idea is like, this is row 1 and this is row 2. What I'm doing is I'm going to create a new matrix, and I don't want this to change. I do want to hold on to that data for a second, but I'm going to get rid of it. I want to do 3.9 times row 1 minus 3.4 times row 2, and that's going to become my new row 2. Okay, the reason why I'm doing that is because this is going to make the LCM of this, and when I add those rows together, it's going to cancel that's going to be 0. And as we do that multiple times, you'll see why it's helpful. Okay, so 3.4 times 3.9, oh, duh. Okay, so let me just get rid of this. So 3.4p plus 1.7n plus 6.4b equals 30.78. So the first equation is not going to change. The second equation is about to change right now. So this becomes 0p plus, now we got to do 3.9 times 1.7 minus 3.4 times 2.2. 2.2, yeah, that's right. That gets us negative 0.85. And then we're going to do 3.9 times 6.4, so we're working on the b's now, minus 3.4 times 5.1, and that gives us 7.62. 7.62b. And then we're going to do 3.9 times 30.78 minus 3.4 times 34.28, and this is going to give us 3.49. Okay, so we're going to do the same process now. So I'm going to take row 1, I'm going to multiply it by 4.8. That comes from here. Then I'm going to subtract 3.4 times row 2. Or I'm sorry, row 3. That's going to become my new row 3. Alright, so 4.8 times row 1 minus 3.4 times row 3. And that's going to go into my new row 3, which I'm going to write at the bottom. Okay, so we're going to get 0p here again. And this is the goal. We wanted to eliminate the coefficient in front of both of these. It's called reduction, Gauss-Jordan reduction or elimination. You've done this with 2x2s. Then same thing, so we're going to do 4.8 times 1.7 minus, oh look, and yeah, 3.4. Minus 3.4 times 2.4. So we're doing the second column now. And okay, so this is where you got, I think you mentioned this, 4.8 times 1.7 minus 3.4 times, yeah, so this eliminated as well, which honestly might be amazing. Let's see if we get rid of the other one. So 4.8 times 6.4 minus 3.4 times 2.2 is 23.24. Okay, and then we're going to do 4.8 times 30.78 minus 3.4 times 34.91, 29.05. So if this one hadn't happened naturally, we would have then done the same thing using this as our new pivot point. We would have taken like this number times this number minus, you know, the same process, but now with column 2, and do it again. So we eliminate this one, then we eliminate this one. And if you get larger matrices, you can keep doing this. But we have a 3x3 matrix here. So now we've done what's called diagonalize this. You can see that the upper triangle is there, and we can solve it now. So I know from the last equation that 23.24b equals that. So 23.24b equals 29.05. So I divide both sides by that, 29.05 over 23.24, which tells us the price of bananas. So 29.05 divided by 23.24, so $1.25. All right, so we got $1.25 for bananas. Now we can take that number and we can substitute it in here to solve the next equation. And let me not erase any work. So now I'm going to back solve equation 2. So this is negative 0.85n plus 7.62 times $1.25 equals 3.49. And then, so we got negative 0.85n equals 3.49 minus whatever this number is here. So 3.49 minus 7.62 times 1.25 gives us negative 6.035. We're going to divide both sides by negative 8.5n. Or by negative 0.85, not n. We want n. And we get 7.1. That's crazy expensive. What is n? Nectarines? Maybe that's true. So n equals 7.1. And then now we've got b and n, so we can find p. So let's go blue now. So we're going to sub it back into this equation. So 3.4p times, so we got 3.4p plus 1.7 times the n we just found is 7.1 plus 6.4 times the banana, which we already found, 1.25, is equal to 30.8. We were 30.78, 30.78. So we'll just simplify. So 3.4p plus 12.07, 12.07 plus 8 equals 30.78. So 3.4p equals, this is 20.07. So this is 30.78 minus 20.07, which is 1071. Let me check that. Yeah. Let me divide both sides by 3.4. Is 3.15. And we should check that. So let me just write this as a point. So we've got 3.15 for the p, then I think n was the middle one, so it's 7.1, 7.1, and 1.25. So that's our point that we should check to see if it's a solution. So we should plug that in for each of these equations. And I super don't want to do that. Let me just do it. I'm very lazy. But no sense in doing work twice that you could, like, if you mess it up, then you have to like do it again. That's terrible. So in some situations, working a little harder initially is the right move. All right, so 3.4 times 3.15 plus 1.7 times 7.1 plus 6.4 times 1.25 equals, okay, so the first equation checked out. Then we've got 3.9, we've got 2.2, and we've got 5.1, 3428, nice. So the second equation worked. I feel pretty confident about this now, but I'm just going to check it since I started. 2.4 and 2.2, 3491. Okay, so this is the solution to the first one. Yeah, but let me ask you this, because you mentioned something about you had an infinite solution in the first one. Did you get an infinite solution for that? Like, was this what you had for the first one, or because this should be right? I'm so lost. Oh, it's because I got the eraser. This should be the answer for part one here. Okay, cool. Nice. Okay. Yeah. All right. So let's check the second one. Sorry, I should have asked you what you got for the first one. So I'm just gonna erase all this since we don't need this anymore. All right. So I'm gonna use a similar process for the next one. Let me set the equations up. Okay. So we've got 4p plus 2.2 n plus 3.5 b equals 33.74. And then you know what? Probably the quick way to do this is just to check this point and see if it solves the other one rather than solve it. Just quickly check and see, because all it does, all you need to do is say whether or not it's changed. You don't need to. It says investigate whether the prices have changed. If so, what they could. Okay. So maybe first we'll check and see if it changed. So, boom. 1.6 n. And you know what? I don't know if you're comfortable with matrix notation. Let me write this. If you haven't seen this before, it might blow your mind, but. There's no reason that we have to keep writing these variables. We know that they're like stacked. So we can encode this matrix object in such a way that we know where P, N, and B are. And this saves us a lot of writing. Let me know if you're cool with this. Where did I skipped one? Oh, yeah, I just totally skipped one. 3.4, 1.1, and 29.58. Cool. Well, actually, maybe that was what you responded earlier. Yeah, let me know if you're comfortable. Do you see what I did? I just took out the variables. Essentially, this is called a coefficient matrix, which you will learn about in linear algebra if you haven't taken that already. All right, so then this is going to be like the first operation is going to be 5 times row 1 minus 4 times row 2. That's going to be our new row 2. Let me just move this up. Oh, first let me say what do what I actually said I was going to do. I'm just going to test the points and see if it doesn't solve it. So I'm going to do the same thing. I'm going to plug this point into each equation and see if it solves the new system. So 3.15 times 4 plus 7.1 times 2.2 plus 1.25 times 3.5, and that equals, this doesn't solve it. So I plugged it into the first equation and it doesn't solve it, which means now it says what they could have changed to. So we have to solve this one, which is super annoying. Okay, back to this. So I'm going to do a linear combination of these two rows, the 5 times row 1 minus 4 times row 2, and we'll get, that'll be our new row 2. So let me leave row 1 the way it is. And then this is going to be 0, so 5, so this is 2.2 times 5 is 11, minus 4 times 1.6 gives us 4.6, and then 5 times 3.5 minus 4 times 4.7 gives us negative 1.3, 5 times 3.5 minus 4 times 4.7, okay. 5 times 33.74 minus 4 times 35.82 gives us 25.42. Okay, so now to get the third row, I'm going to do 2 times row 1 minus 4 times row 3. That's going to be our new row 3. Okay, so 2 times, obviously this is going to give us 0. Okay, so 2 times 2.2 minus 4 times 3.4 is negative 9.2, and then oh, what do you mean by cross multiplied? Oh, let me see. Times 2 gives. Oh, I see. In these two rows are gonna combine. I got you. Let me check just to be sure. 2 times 2.2 minus 4 times 1.1 gives us 0. So that goes to here, and then 2 times. Oh, look, I made a mistake. That's right. Sorry. So 2 times row 1, 2 times 2.2, 2 times 2.2 minus 4 times 3.4. Okay, then we got 2 times 3.5 minus 4 times 1.1, 2.6. Got you. Okay, yeah, you're right. It looks like it. Let me check the last one. And if that's the case, this is a mistake, for sure. Yeah. Okay. Your solution of this problem should show all the relevant calculations, use the correct mathematical statements, clearly communicate your strategy method at each stage of the solution. Yeah, so there are infinitely many solutions which you found. These are constant multiple of each other. It's -2. So we could zero out this last row, and our things are pears, nectarines, bananas. So this is like P and B. So let's parameterize, if I'm saying that correctly, the solution based on B. So let's say whatever you choose the price of bananas to be, you can figure out the others with relation to that. So let's say B equals B, and we'll put everything in terms of B. So we'll have 4.6n minus 1.3b, and then equals 25.42. Or you could make the different parameter. Let's say b equals t. So all right, b equals t. So our parameter is t now. Then I'll add 1.3t to both sides. 4.6n equals 25. Here, let me put it. Does that mean all equated to? Oh, they all. There should be more information in this one. I don't see that one. Like the first equation should still exist, right? Just the last two. were the same. So then n equals 1.3t plus 25.42 over 0.6. And then we can dump both of those into equation 1. So we got 4p plus 2.2 times 1.3t plus 25.42 over 4.6. Plus 3.5 times b, which is t, equals 33.74. Does it make sense what I'm doing right now? No, I think I understand what you're saying. Like the equation 2 and equation 3 ended up being like constant multiples of each other. Like 2 times equation 2 would give you equation 3, or like negative 2 times that would give you equation 3. So you, or even like you got them equal to each other. What that means is that you, yeah, exactly. I'm subbing whatever I found into, I put b in terms of t, then I use that to find n in terms of t, and I'm going to put that back into the first one. So every we'll be able to just generate solutions by choosing a value for t. Okay, yeah, I'm with you. So you basically found its infinite solutions, and then you had to roll with that from there. So this is 18.96t plus 55.924 over 4.6 equals 33.74. Right. I hate doing this with decimals. It's so annoying. So we're going to go Oh, right here. So what I did was, at this step, I got a common denominator, so I did like 4.6 over 4.6, and that, that's like 13-ish, 15, or it's like 15, and then I added that to here. Let me know if that makes sense. And the reason I did that is just because I didn't want to carry it around a lot, so I just got rid of it. And then it's combined in there, and then I just brought everything over. I did the same thing here. That was like 155 something. Once I did 4.6 over 4.6 multiplied by that, it was like 155. And then I subtracted this 55, and that's where 99.28 came from. But if you put that on your paper, how I wrote it, hopefully you can copy this. I guess you can rewind it later and press pause if you need it, but your teacher will know exactly what you did. And then I'm just going to put this as fractions because I hate decimals. I think it just looks bad. Honestly, we can get this all over 230. We can make this over 232. Something like that. And then I'm going to do the same thing here. So 1.3 divided by 4.6. Minus 5. The reason why you can't do that, let me check. So 2.86t. Oh, okay, I'm with you. So yeah, the reason why you can't do that is because let's look at this specifically. So I'm gonna pull this here. Control C. Turn this off, and then let's go. All right. So let's look at this thing. This has the same shape as like. We really can ignore this here. We don't need that. And let's look at this. So we've got a number times t plus another number divided by another number. And we want to add a completely different number to this. So this is like a fraction. And I want to, this has a t as well. So this is like a like term with this. But if you think about how you add fractions, this first bit is at over c plus b over c, and then we've got dt. Now here dt has a common denominator. It doesn't have a common denominator. Its denominator is 1. So I need to get a common denominator between these two in order to be able to add them. So what I did was I multiplied by 4.6 here over 4.6. This is equal to 1. You can always multiply by 1. And then once they have a common denominator, which here would be like c over c, but up here it's 4.6 over 4.6, then I can add them together. Does that make sense? You would, if these were integer values instead of decimals, you would just do this in your head like nothing, or maybe the calculation you wouldn't do in your head, but the procedure would make total sense to you. It just looks weird because it's decimals. And that's a very good question, by the way. I think we have like a lag, so I'm going to pull up the thing again, but let me know if I should add any clarity to that. Yeah, so I would say this is my solution here. To the second part. Yeah. Oh, have I done it wrong? Let me go back to this. So we've got 3.5 times 4.6. So 3.5 times 4.6 gives us, let's highlight this again. No, that's a good question also. So let me take the second question first. You can't solve for n and b. So if you'll notice what I did, this is called parameterize. I made a parameter. My parameter is t. And so here my parameter is t. Is this working? Come on, then. Why is this not working? Super annoying. Oh, because I'm on the wrong thing. Oh, sorry. So I made a parameter t for b, and b was the equation that we solved for. We found that in the last equation, man, I erased it, but if you could scroll back in the video, you'll remember that when we solved this, this basically we could have turned this whole equation to 0. The prices have changed. That's a good question. So the way I determined that the prices changed was by plugging in the old solution, this solution, and it didn't solve the first equation. So since it didn't solve the first equation, I know it couldn't solve the system, if that makes sense. So the price must have changed. That's what caused me to start going down and actually doing the solution again. Yeah, that's a really good question. That's like an interpretation question, which is the best kind of question. And another way that you could answer that question is to say that, we went through the process of solving it and we didn't get this solution, so the prices must have changed, right? Yeah, so I guess it's a matter of perspective and what process you followed first. I think since it's, the way I did it was I checked the first solution to see if it was a solution of this system as well, and it wasn't. So that's probably what I would say. And there's this note at the end about your discussion has to be good. So I think before you get into solving the second part, like week 4, 5, and 6, you should say that. Okay, cool. All right, nice. And then let me go back into answering your question about this thing. All right. So this 4p is just hanging out here. Where did we go? Why is this doing this? Sorry. I'm having an issue with my thing now. Why is it doing that? Okay, you know what I'm going to do? Is it locked? Why is it doing this? I don't. Oh, is it too small? Yeah. Okay. There we go. My bad. All right. So looking at this, So let me just do these operations. I think that'll be the easiest thing. So I'm going to distribute this 2.2 first. And it's going to be plus 2.86t plus 5.42 equals 55.924 all over 4.6 plus 3.5t is 33.74. Now I want to add this to this, but I can't do it yet because they don't have a common denominator. So let me break this apart. This is going to be 2.86t over 4.6 plus 55.924 over 4.6 plus 3.5t equals 33.74. So here you can see like these numbers don't have the same denominator, so I can't add them yet. And the way that you get a common denominator is you multiply this by 1. I'm going to represent 1 as 4.6 over 4.6. Now, if 4.6 over 4.6, anytime you divide a number by itself, that's equal to 1. And you can always multiply by 1 because it won't change the number. It'll just make it look different since we represented it this way. So now I do 3.5 times 4.6, and I get 16.1. So this new equation is 4p plus 2.86t over 4.6 plus 55.924 over 4.6 plus, we got 16.1t over 4.6. And just to be clear, this is the same as this. These are the same numbers. Like if you punch this into your calculator, you'll get 3.5t. I just did that, so now I've got common denominator here. I can add this to this. And then, what should we get? So we'll get 4p plus 2.86 plus 16.1 is 18.96 over 4.6. And then we're going to add back the 55.924 over 4.6. Now, is it practical to keep doing this? I don't know. You know, you could totally do it a different way. I just wanted to keep everything packaged together so it was easier to move around because I knew I had to cancel by subtraction. That's the only reason why I did it that way. Realistically, back up here, I could have divided 2.86 by 4.6 and got no, like, didn't have to ever deal with this. I could have divided this too, didn't ever have to deal with the denominator. I'm very comfortable with fractions, so for me that's something that I would much rather deal with a fraction than with a decimal. I hate decimals. I think they look disgusting. Yeah, let me know if that kind of clears up the question on like how I did that, why I did that. Yeah, good question. Okay, so this is really, really hard for people to understand. Let me pull up the old problem again. And then, what do I want? Do I want this? Don't want that. Okay. So this is really weird, right? But our solution should take the form of a point, P, N, B. The solution to our thing is going to be this point. It's 116 minus 237t over 230, comma, 65t plus 1271 over 230, comma, t. Now, let's think about how we interpret this. this is a line in 3 dimensions. That's super weird. You just choose a value for t and you get a solution. Choose a different value for t, get a new solution. And that's that idea that we have infinitely many solutions. And you said this yourself, actually, which I thought was pretty brilliant. I just so happen to have a bunch of pieces of paper here. So if you look at my very tiny camera, and you imagine that we have 3 planes here, and they all intersect at this line, right? That would be like the equation of that line. That's the kind of thing that's going on here. Or actually, maybe an easier way to do this would be like, we fold this paper. So this is 2 planes, and then we just intersect this with a 3rd plane, like this. And then the little line that they're going down there is the line that we described, right? If that makes sense. So 3D is really confusing, but to answer your question, this is called a parameterized solution. You choose a value for t and you can generate a solution. So you could put 1 for t and generate a solution. Okay, nice. Yes. Yeah, man, you're super good at math. You're very intuitive. That's cool. That was really hard for me to understand whenever I took linear algebra. I couldn't connect it back to the planes and everything. All right, I'm going to do one for this other person. But if you got more questions, post them. Yes, and you know, for this one, you should say like I got infinite many solutions, and you know, I don't know the price of any of the things, but if you can tell me the price of bananas, boom, I'll plug that in for t and generate the rest of them, or you know, tell me the price of any of them, I'll figure out t and figure out the rest. So, but your teacher will like your professor knows that this is, you know what I'm saying, like. Your professor understands that this is going to happen, and if you just let them know, like, I got infinitely many solutions, here's my line that solves this thing, any point that's on that line, and you can generate those points by choosing values of t, will tell you what the solution is. So if they give you one price of peaches, nectarines, or was it pears, I don't even remember, p, n, or b, if they give you any of those values, you can generate the other ones using our little parameterized solution there, which is cool. So you gave the line which solves the intersection of all the planes. All right, so now we're about to pull up a problem for Rock and Roll Legend. It's very cool. So, yeah, you're very welcome. Right. Yeah, you know, and a lot of times your teacher's not going to be, they possibly didn't study math. They maybe studied like engineering or something like that. It happens a lot of the time. And you know how it is in school, you know, there's like 20, 30 people in the classroom and they're not asking questions maybe, they're just sitting there taking notes, and then if they ask a question, the teacher might not know how to answer it. You know, they don't really understand why, they just know the procedure. Yeah, it's not a good situation. The best thing you can do is get a tutor. Find someone who's taken that class before and work with them, or just go online, find a tutor, and really, you know, get the help you need. A lot of people don't realize like this is tutoring. This is what I do whenever I tutor people, and it's a lot of people have this stigma about tutoring, but it's definitely, you know, it's a privilege. Just go find it. There's a lot of people that will help you. Following questions are not related. All right, so consider the function g of x equals 5x squared plus 20x minus 10. Determine the inverse. Okay, so we kind of started this one before, but I just want to do something real quick. How do I? There we go. Size. Don't want the size to change. Stop. Okay. Don't want string. Strength change. Override push. Okay. Nice. All right. So let's say we got some axes here. And I don't know exactly what this function's graph looks like. Yeah, thank you for the sub. I appreciate it. And, you know, always DM me if you have something. If I'm not on there, you know, I get on like every night basically. So I'm trying to do once a day. I'm trying to do a live stream. But yeah, if you have any questions, always bring them to me. I'd love to help. So this graph, like, this is not exactly the graph. I don't know what this graph looks like. It's a parabola. And the question, though, is what's the inverse of this thing? You'll recall from your class discussion that the inverse of this graph is whatever the graph is reflected across the line y equals x. So there's the line y equals x, and then I'm going to draw some like reflection of this thing. All right, you have a good night, man. So let's say it's like, I don't know, this. Woo. Okay, woof. Terrible. Just downright bad. Okay, so let's say that's the inverse, right? But then you really have to think about this. This is not a function. It doesn't pass the vertical line test. So we can, you know, you can see right here, oh, that's a great vertical line, right? We can see right here that we've got these 2 points there. Oh, got this point here and here. So I already know, before I even start trying to solve this thing, that this is not a function. Okay? That's something that I want you to keep in mind. But, you know, we still got to do this, so let's go ahead and try it. I think the easiest thing would be to take this g of x and do complete the square to this thing maybe. So let's go 5 times x squared plus 4x minus 2. So I just factored out the 5. And just so I don't have to deal with this, I'm going to divide both sides by 5. So g of x over 5 equals... You can't always do that, depending on what you're doing when you complete the square. But so then I want to add 1/2 of this b coefficient here squared to both sides. So 1/2 of it is 2. So I'm going to go g of x over 5, and 2 squared is 4. So I'm going to add 4 to both sides. So 1/2 of 4 squared, it happens to also be 4. So this is x squared plus 4x minus 2 plus 4. So there I added 4 to both sides. And then this should now be a perfect square. Let's check and see. So we've got g of x over 5 plus 4 equals x squared. So these two add up to be 2. No, that's not right. Oh, duh. That's because I did it wrong. I have to add 2 here to both sides first. So g of x over 5 plus 2 equals x squared plus 4x. And now I'm going to add 1/2 of 4 squared to both sides. So g of x over 5 plus 2 plus 4 equals x squared plus 4x plus 4. This is a perfect square right there. This is the same as x plus 2 squared. I'm going to combine the like terms there. So g of x over 5 plus 6 equals x plus 2 squared. And then now we should be able to swap y and x. So let's call this y. Ah, nice. Okay, cool. That's awesome. Yeah, if you want to post your question on on Reddit. Do you have a Reddit account? My username is that on Reddit. If you DM it to me, I'll do yours next. Okay, so then I'm going to swap x and y right now. So we'll have x over 5 plus 6 equals y plus 2 squared. And then let's go ahead and solve for y now. So I'll take the square root of both sides. Right here, when we do the square root of both sides, we get plus or minus. So that's why this thing is not a function. And then we'll subtract 2 from both sides. So y equals 2, or negative 2 rather, plus or minus the square root of x over 5 plus 6. And then this y now is g inverse of x. I'm going to do whole. This is g inverse of x. Yeah, so that's the answer there. I want to go back and just look at this question. Boom, graph. Okay, so now we have to graph both of these and state whether or not. Yeah, okay. Super annoying. So let me. I'm just gonna punch this into Desmos for you. Well, I guess you need to know how to graph it. Whoops. All right, so a good way to graph anything is just plug in values of x. So that's one way to do it. All right, sweet. Yeah, I got you next. Do you have to go? Well, in this problem, it says like first find that, but then here it says graph it on part B. So you may not have to graph it for your homework, but this user they needed the graph. I feel like it just popped up weird here. Oh, actually, I already factored this thing, so this will be easy. Right? Did I factor? No, I can't factor that. Let's go with 0 is negative 2, negative 10. So this would be like negative 10. This would be 10. If we got 1, this would be 5 minus 2 is 3, 15. Was negative b 2 equals negative 2. Okay, so I'm looking at just this portion for a second. I'm going to find the axis of symmetry. So h is negative b over 2a. Gives me negative 4 over 2 times 1 is negative 2. So I know the axis of symmetry is negative 2 for that. So it will also be for the full thing. So over here on negative 2, if I plug in negative 2, I get negative 2 squared, which is 4, minus 8 minus 2 is negative 6. Is that right? No, that can't be right. Negative 6. Negative 6 times 5 is negative 30, so let's call this, no, that's negative 30 down here. So you're going to get, that's negative 2, then at 0 you get negative 10, and then, so this would be here. Yeah, so this looks crazy steep. That's the first one. Oh my goodness. And yeah, something like that. Terrible. you could figure out what these zeros are for this. Be -4 plus or minus the square root of 4 squared minus 4 times 1 times c is -2 all over 2. And what is that going to be? 16 plus 8 is 24. 4 root 6. Yeah, this is a crazy number. I don't even know. I'm not even trying to. It's something like that. You figure out what the zeros are. Or just graph it on Desmos. I'm going to graph it on Desmos at the end, but you guys know how to graph parabolas. Then you take this thing and you put the line y equals x here. Alright, that's the line y equals x. Then you just reflect everything across that. So it's going to look crazy. Because I'm so good at drawing. It's like -30. Okay, something like that. These should be reflected across that line. That's really hard to do for me. So let me put it on Desmos. I just want to give you a half-hearted attempt so you can think about how to graph this if you needed to. Alright, what do we get? 5x squared plus 20x minus 10, and then what was our reciprocal? So we're going to get -2 plus square root of x over 5 plus 6. And then I got to copy the negative of that as well. Minus. Okay. This screenshot in here so you can see this as well. And that's not what I want. There it is. Alright, so that's how it should look, which is pretty close. Yeah, so we found this point and we found this point, and so that means that we know this point and this point are on there, and then we also knew this point and this point. So that's, enough to get a nice looking sketch going. And then you can see that these zeros were just like gross values, which is why you can estimate them, but I hate estimating. Okay, looks like we got, nice. I'm loving the usernames today. Okay. Right, here comes our next one. Okay, so given this function, identify the base function. Okay, cool. Yeah. For me, this is, oh, my calibration got all messed up in the middle of the last one. I didn't even notice it. All right, there it is. So this is like some function square root of x. That's where this comes from. And you can see that's the base function. There's also, you could think of this as a linear combination, or a composition of this function and like 2x minus 16, you know, which is underneath the radical there. But we can do everything with this. So if we take this, I want to replace x with 2x minus 16. So I'm going to take f of 2x minus 16. This gets me the square root of 2x minus 16. And if you don't understand function composition, like if you are just learning function composition, or maybe you learned it last year, this might seem really hard to you. If you stick with this over the years, you'll get much better at this. Now I need this to be times 1/5, so I'm going to multiply both sides of my situation here by 1/5. So 1/5 of f of 2x minus 16 equals 1/5 times 2x minus 16. So that's cool. And then I need to add -3 to both sides as well. So I'll go 1/5. Let me put this over because this is actually g of x now. So this is 1/5 f of 2x minus 16 minus 3 equals 1/5 root 2x minus 16 minus 3. Is that right? Yeah, we're good to go. So that's how I could show that the base function is root x there. Describe in appropriate order the transformations that must be applied to obtain g of x. So that's what we just did. And you could even start with this. So like, let me add in a little step here. So let's say go this direction and then we'll go this direction. So first thing we want to do is I want to do f of x minus 8. Okay, the way I found x minus 8 was I started with 2x minus 16 and I factored out the 2. So the first shift then is you shift it to the right 8. This shifts to the right 8. When you subtract inside the parentheses, that's the argument of the function. When you subtract inside the argument of the function, that shifts to the right. Add would shift left. After that, you're going to do the multiplication by 2. So then you're going to go f of 2 times x minus 8. What that does is, since it's inside, it's the opposite of what you're thinking. It affects the x direction, but it's multiplied by 2, so it shrinks the width by a factor of 2. It shrinks it by half. Okay, it makes it half of its original size. So first we do a right shift. We do a shrink, like shrink it to half of its original size, shrink it by 2, whatever you want to say. That gets you to here now. Then we're going to shrink it vertically by 1/5. And then we're going to move it down. After we shrink it, we're going to move it down by 3. And that's what this does. So inside the argument of the function affects the horizontal direction. Multiplications greater than the absolute value of 1 will shrink instead of stretch. You would expect them to stretch. Like if you multiply 3 or 4 or 5, you would expect it to stretch, but it doesn't. It shrinks it because it's inside. Everything inside is backwards. The minus 8, you would expect it to shift left, but it's inside, so it shifts right. Then we start applying our stuff outside of the argument. So we multiply by 1/5. That's a vertical. Outside affects the vertical. Behaves the way you think it does. So multiplying by 1/5 shrinks by 1/5. And then minus 3 shifts down. And so I didn't even read this question, B, but I sensed that's what was coming. Oh, yeah, and I got lucky. I just chose f of x. So that's how you figure those shifts out. A lot of people will tell you, there's like an acronym my daughter taught me recently. It's in one of my other streams. You can like look back through it to help memorize this, but I don't memorize anything. I can't memorize. All I do is try to understand like what's going on, and this is how I'm able to figure it out each time. So this is like this is the starting function. You shift right by 8. You shrink horizontally by a factor of 2. That gets you to here. This is like step 3 also. Then you shrink vertically by a factor of 1/5. Then you move down 3. Okay. So then we have to sketch both of these now. Sketch f of x and g. Okay. Let's go here and here, and I had a student lose a ton of points recently on this right here. They forgot to put X and Y, right? So, and even probably what I would do is I would do like, call this f of x, and then put a different color for g of x. So f of x, we're going to have normal square root function. So then you just need to label up your axes, like this could be 1 and 1. So put 1 1s on there. And you can put more scale if you want to. Honestly, maybe I should graph a couple other points first, because that'll help me. So this is going to be 2, and then we got actually 2, 3, 4. This will be 2. So then this point's on here. So, you know, like, this will help you graph if you put a few points down. Yeah, anyway. Then, oh man, see, I set my axes up terribly. Let me set this up better. Yeah, so I guess what I'll do is I want one point to be at 0, 0, but I want that point to be shifted right 8, and I want it to be shifted down 3. So that point becomes, let's say 8, -3. So I'll make this green here. So that's going to be this green point. Then, since I've got this scale set, so that's -3. So this is like 3, 6. Then I know I've got 1, 1, and I've got 4, 2. So this is the original function, something like that. Then the green one is going to be the other. And I should have 1, 1. All right, let's find some other points for this. So another way we could find this is going to be 16 divided by 2. Yeah. So we know we need to shrink it by 1/5, and we also need to shrink it this way by 1/2, so which actually doubles the height. It's kind of weird, but so this is going to be like, let's actually find out what it's 0, 3, 15 squares can be 625, 225, 225 minus 16 divided by 2 minus 16 divided by 2, 104. Yeah, this doesn't make much sense to really deal with this, but it's gonna be equal to 0 at 15. Yeah, so this thing just goes like way out here. It looks crazy. I don't even want to try and do this. I'm gonna put it on Desmos. Minus 16 minus 3, and then let's go to the square root of x I don't know why I put so much room on the negative. So what I was having a hard time drawing on that was that this crosses the x-axis really far away. So let me just go negative 10 to 10, negative 10. This is going to be So I'm coming up with a screenshot of this graph here so you can see what I'm trying to draw. Put this off for a second. Import, add images. So this is just, oh, come on now, son. Okay, so here's your graph. Basically what I did was I calculated the 0, and it's like whenever 1/5 root 2x minus 16 minus 3 equals 0, I was trying to find that number. So you add 3, multiply by 5, you get root 2x minus 16 equals 15. Square both sides, 2x minus 16 equals 225. Minus 16 divided by 2, x equals, what is this, 209 over 2, so it's like 100 something. It's like 100, oh no, it's plus 16 divided by 2. So 30, 41, 241 over 2, so this is like 220.5, and, or 120.5, so it's like right here, is the 0, and we already knew this point. That was pretty easy to calculate. But it's hard to graph based off of transformations. It's like very hard. So I don't ever really do that. I'll try to find a couple of points and then sketch it. But then you have to determine your axes pretty early on. Anyway, all that to say, this is your graph. And then let's go back to this for a second. So we got to state the domain and range of both functions. So let's talk about f of x is root x. So x here has to be greater than or equal to 0. Because you can have the square root of 0. 0 times 0, but you can't have the square root of any negative numbers. So x has to be from 0 to infinity, including 0. And then f of x has to be the same, 0 to infinity. So think about, like, what's the square root of 0? Well, it is 0. So f can be 0, and then as x goes up, so does f of x. So that's the domain and range for, this is domain range for f of x, and then g was the function that we were given, I think. Yeah. So for g, you have to think about what are the restrictions on the square root function. Well, everything under the square root function needs to be greater than or equal to 0, because it can't be negative. So 2x minus 16 has to be greater than or equal to 0, which means you add 16 divided by 2. X has to be greater than or equal to 8, which is what we saw in our graph. So you could also write this as x is on the interval from 8 to infinity. And then at that point, when you plug in 8, y is negative 3. So if this is like, I plug in 8, that makes that 0, right? We know that because that's how we set this up. 0 times 1/5 is 0. Minus 3 is negative 3. So the lowest value y can be is -3, and it only goes up from there. As x increases, so does g of x. Another way I like to think about this graphically is, think about if you shined a light from the right side of this graph, it would cast a shadow on the y-axis. Like, where does the shadow hit? Or from the left, it doesn't matter which way you shine the light from. That's another way of thinking of that, which some people help. Yeah, are there any questions on that? I know I did kind of like a hasty job. I'm getting a little tired. I don't know if you're still with us. I'll give you a second to catch up just in case you rewound it at all. Yeah, definitely like follow me on Reddit and sub to the stream, because like anytime I go live, you can just pop in and post questions. You know, I think I'm gonna try and do this every night, at least for the next couple of months. I'm just like trying to get subscribers to see what I can do. This is probably one of my more successful videos so far, just in terms of like Cody was in here asking questions the whole time, which was really cool. It made it a lot easier for me to do it because it's okay. Cool. All right, yeah, man. If you ever need any more help, just let me know. What are we gonna do? Yeah, unless you have any other questions, I think I'm done for the night. All right. Thanks for the question. Ask me anytime you need help. Just send me a message. You have a good night. I'll see you next time. Okay, word. Yeah. As soon as you get your homework, launch it over to me and we'll get it done. Have a good night.